All right, this is section 724. We're still in the laws of sines and cosines unit. We're going to take a look more specifically at the law of sines SSA case, or ASS, which we call that the ambiguous case. So we're going to solve oblique triangles using the law of sines still, and then we're going to use the ambiguous checklist to determine the number of solutions. And this is basically the new piece. So, like I said, we're going to focus on the SSA case. If you remember, that is our law of sines, and we could flip it. We can do sine A over A equals sine B over B equals sine C over C. And the reason why we call this SSA case the ambiguous case is because we can actually represent two triangles with the corresponding information. And so let's look at an example here. With this triangle here, the only information I have is this angle A, the opposite side A, and the adjacent side that we're going to call B. Now, it just depends on how we orient the triangle. It doesn't have to be AB, right? This could be angle C, but then this opposite is side C, and this could be A or B. So that's the only thing we have to pay attention to. I know that a lot of the things that I use is A and B, but it could be any reference. It could be any angle that we're talking about here. And so you can actually create a different triangle. So notice that length here, I never changed this length. I never changed this length, and I never changed that angle. And I was actually able to create another triangle with that same information. And so that is the reason why we call this the ambiguous case, is because with this information, it is possible for us to be able to create those two different triangles. So there are three conditions that we actually have to examine. The first condition is going to be, is this angle acute? The second is going to be, well, we're basically comparing the opposite side to the adjacent side, and we're asking ourselves, is this side smaller than the adjacent side? So we're taking them and we're comparing them to see, is A smaller than B? And then the third is going to be the height of the triangle. And so we're comparing, is the height of the triangle compared to A, is the height smaller, is the height larger? And so we make that level of comparison. Is this side A smaller than that H? And so I took all that information and I put it on this flow chart just for you. So this means a decision that you make, yes or no, and then this is our conclusion from that, and then here's our ambiguous triangle. Now, like I said, you could easily just say, you know, even though I say in this thing that's given angle A, you could say that this is x, little x, and y, right? It doesn't matter as long as the given angle is in this spot, and then that's the side opposite, right? So I could give you triangle, let's say CBA, and this is 70 degrees, and then I have 5 and 7. So then my ambiguous triangle that I'm doing here is this is 70 degrees, that's 7, and that's 5. This is going to be the A that I'm talking about for this checklist. Even though the reality is it's C, we're talking about A. Now I know it's not blue. Maybe I'll do this. Look at this. Oh man. Look at this. We want to get that down. This is really important. We want to get this down because we're going to use this to be able to determine the number of triangles that we're going to have. So let's actually use it. So I have it here off to the side. And so this first one, given the angle is 16, A is 15, and B is 17. Okay, so what we're going to do is we're going to compare it. So is your given angle greater than 90 degrees? So is my given angle greater than 90 degrees? No. Okay, so now we're here. Is my opposite side, that's A, is that bigger than adjacent side B? Well, in this instance, since my given angle is A, let's kind of draw the little triangle here. It'll help us out. So we have 16, 15, and 17. So is 15 bigger than 17? The answer is no. So we're down to here. Does A, so 15, equal 17 sine of 16 degrees? Well, we got to get a calculator for that. So enter in your calculator, 17 sine of 16 degrees. Okay, I get, this is 4.685. So the answer is no. So then the next one, is your opposite side less than that? So we're looking at this. So is A smaller than that? The answer is no. So therefore, it's going to be two solutions. So I know that with that given information, it's going to give me two triangles. So get another one. So first question, is your given angle? So now my given angle is C. So my given angle is 41. This is the side opposite, so 14, and this is 8. Remember, given angle, side opposite, adjacent. So is my given angle greater than 90 degrees? No. Is my side opposite greater than B? So is this greater than this? The answer is yes, so it's going to be one solution. So get one more. I want you guys to try this one out real quick, and then we'll go over it. Notice it's blue, so copy that down. Okay, let's go over it. So the first thing, so drawing out the little ambiguous triangle. So my given is 16, opposite is 21, adjacent is 28. Right? Remember I mentioned this already. This B, B, and A don't necessarily correspond to this. This is your given angle, side opposite, side adjacent. So in this instance, is my given angle greater than 90 degrees? No. Is my side opposite greater than side adjacent? No. Does my side opposite equal my side adjacent times the sine of my given angle? So does 21 equal 28 sine of 16 degrees? Okay, we have to use our calculator for that. So 28 sine of 16 degrees, that gives us 7.71. So the answer is no. Now, is this less than that? No. So therefore, it's two solutions. All right, so we spent the time going through that. We spent the time talking about how many solutions that we can get. So now what do we do with it, right? Once I know that I have two triangles, what do I do with it? So given this information here, solving this given triangle, I know that it's SSA. So it's going to be side, side, angle. And then going through that process that we just went through, I'm not going to spend a whole lot of time on that because we just spent time on it. But going through that little ambiguous checklist, all that different stuff, we know that it's actually going to be two different triangles. So we go through and we solve the first triangle. We just go through, we have our first triangle, and we solve it like normal. So we're going to use the law of sines. And so the first one that I'm going to be able to find is B, because I at least have side B. I don't have the angle. I don't have any information for C, so I can't do anything with it. So plugging the values in, 12.8, 58, 11.4. Multiply both sides by 12.8, because I got to get B by itself. And then inverse to both sides, enter that in your calculator, and you get B is 72.2. We need to remember the first angle that we find. This is going to be very important. You're going to see why in a second. So we're just going to hold on to that. Then, now I can solve the rest of the triangle like normal. I could find angle C, 180 degrees minus the rest. So minus the two other angles that I found, and I get 49.8. And then I can find my measure C, plug the values in, multiply both sides by sine 49.8, plug that in your calculator, and you get 10.3. All right, so we completely found all the values for that first triangle. So I said this is important. The first angle that you find is important. And so what we're going to do to be able to do that, to find the second angle, this is the trick. You take 180 degrees and you're going to subtract it. So that's essentially to find that angle. We have this one. How do we find that one? And so to find that missing one, what we're going to do is we take 180 degrees and you subtract it from the first angle that you found. And so there's my second triangle. And so if the first angle that I found was 72.2, then to find this next angle, I do 180 degrees minus that 72.2, which gives me 107.8. Then just solve the triangle like normal. 180 degrees minus the rest to find angle C. And then I can do C over sine C equals A over sine A to be able to find the missing information there. And I get value for C. So let me back that up real quick. So we completed this triangle all the way through. To find this missing angle here, we know there are those two triangles. So since this was the first one, to find it, you do 180 degrees minus, gives us that new angle there. And then you just solve this triangle like normal. So now angle C is missing, and now I can use the law of sines to find the missing value there. All right, so let us conclude this lesson. So what did we talk about today? We talked about the ambiguous case, side-side angle or angle side-side for the law of sines. It's important because the information's ambiguous, and there's a chance that we could actually have no triangle because it makes no sense, two triangles, or one triangle. And so that's why we had to use that flow chart and that checklist to be able to figure out which is what the ambiguous case is. Now, one thing to trust is the math. That is a very important piece here, because if you guys know that it's SSA or angle side side, and you go through and you start completing and you start finding it, if you do 180 degrees minus that first angle that we found to try and get the new angle, if there are two triangles, it will work. Like, you'll literally be able to create another triangle. If the 180 degrees minus that doesn't work, then you know, and then you're able to find all the values for the triangle here, then you only have one triangle. And the way that you know is when you do 180 degrees minus that first angle and you start adding the two angles together, it's going to be bigger than 180 degrees. You can't have more than 180 degrees in a triangle. And then the way that you know that it's not even a triangle at all is when you actually take the triangle and you start going through and solving it, you're going to get an error, an undefined value. Now, that's if we make sure we enter everything in the calculator right. So this does conclude our lesson. If you have any other questions, please leave them in the comments.